You wake up at 6:47 a.m. with the unmistakable feeling that something just happened to you. A few seconds ago, you were somewhere else entirely. A childhood house that doesn't exist anymore. A conversation with someone you haven't spoken to in a decade. A chase down a hallway that kept stretching longer the faster you ran. And then, almost cruelly, it's gone. By the time you're brushing your teeth, you can't even remember who was chasing you. This happens to you roughly every 90 minutes, every night, for your entire life. By the time the average person reaches 80, they will have spent around 6 years of their existence dreaming. 6 years of vivid, often bizarre, sometimes terrifying experiences that the conscious mind almost never gets to keep. It raises an obvious but oddly under-asked question. Why would evolution build something this elaborate, this costly, and then immediately erase nearly all of it? The honest answer is that scientists don't fully agree. But the last 70 years of sleep research have produced a set of theories that, taken together, paint a strange and surprisingly coherent picture of what's actually happening inside your skull at night, and why losing access to it might be just as important as the dreaming itself. The discovery that changed everything. For most of human history, dreaming was the property of philosophers, priests, and mystics, not scientists. That changed in 1953, when a University of Chicago graduate student named Eugene Aserinsky was studying sleep in young children, including his own son. Using electrodes to monitor eye movement, he noticed something odd. At certain points during the night, sleepers' eyes would dart back and forth rapidly beneath closed lids, almost as if they were watching something. Aserinsky, working with his advisor Nathaniel Kleitman, woke subjects during these episodes and asked what was happening. Overwhelmingly, people reported vivid, active dreams. Outside these windows, when woken from other stages of sleep, they rarely reported anything at all. The pair had identified what we now call REM sleep, rapid eye movement sleep, and in doing so, they accidentally discovered that the sleeping brain wasn't quiet. It was, in some ways, almost as active as the waking one. Later, brain imaging studies confirmed just how active. During REM sleep, regions like the visual cortex, the motor cortex, and especially the amygdala, the brain's threat detection and emotional processing center, light up with activity levels close to, and sometimes exceeding, those seen during waking hours. Meanwhile, the prefrontal cortex, the region responsible for logic, planning, and self-control, goes comparatively quiet. That single fact may explain more about the strangeness of dreams than any other piece of evidence scientists have. You're running a nearly fully active emotional and sensory brain with the rational, reality-checking part of it switched almost completely off. That's why dreams feel intensely real in the moment and only seem absurd in hindsight. The part of your brain that would normally flag, "Wait, I can't actually fly," simply isn't doing its job. A brain rehearsing for danger. One of the most compelling explanations for why we dream comes from Finnish neuroscientist Antti Revonsuo, who proposed something called the threat simulation theory in the early 2000s. His argument was straightforward. Dreaming exists because it gave our ancestors a way to rehearse dangerous situations without the actual danger. Revonsuo and later researchers analyzed thousands of dream reports and found a consistent pattern. Negative emotions dominate dream content far more than positive ones, and threatening scenarios, being chased, falling, confronted, attacked, lost, appear disproportionately, often compared to mundane daily life. Children, who historically faced more real environmental threats than modern adults, report a higher rate of threat-based dreams than adults do. People living through war zones, abuse, or chronic danger show dream content that mirrors and amplifies those threats, almost as if the brain were running extra simulations because the stakes demanded it. Under this theory, the dreaming brain functions something like a flight simulator that never turns off. You die in your dreams, fall in your dreams, run from things in your dreams, and each time your brain gets a low-stakes rehearsal of a high-stakes response. The muscle paralysis that accompanies REM sleep. Your body is functionally locked in place while this happens, which is why you can't actually move during. A nightmare, no matter how hard you try, exists specifically so you can rehearse fight-or-flight responses without leaping out of bed and acting them out. It's a tidy explanation, and it accounts for a lot. But it doesn't account for everything. Plenty of dreams have nothing to do with threat. You don't typically dream about practicing your tennis serve or running through a grocery list, even though those are far more common daily activities than being chased through a forest. If dreaming were purely about rehearsing survival skills, the content should be more evenly distributed across the kinds of problems we actually face. It isn't. So researchers went looking for a second explanation: the night shift of memory. A separate, and in many ways more data-backed line of research points to memory consolidation. The basic idea is that while you sleep, your brain is sorting through everything that happened to you during the day, deciding what to keep, what to discard, and how to file the keepers into long-term storage. This isn't speculation. In studies dating back to the work of psychologist Matthew Walker and his team at UC Berkeley, researchers found that people who were taught a new skill, a sequence of finger movements, a navigation task, a piece of information, performed measurably better on that task after a night of sleep that included REM, compared to people who learned the same material but were deprived of REM sleep afterward. The brain appeared to be replaying and strengthening the relevant neural pathways during the night, almost rehearsing the day's lessons in the background. Animal studies make the mechanism even more vivid. In experiments with rats navigating mazes, neuroscientists recorded the specific firing patterns of neurons as the animals ran through the maze during the day. Later, while the rats slept, the same neurons fired in the same sequences. The rats were, in a measurable, literal sense, replaying their day. Some scientists believe something similar happens in human dreams, just dressed up in far stranger imagery. Because the brain isn't just replaying memories directly. It appears to be cross-referencing them, linking a conversation from Tuesday with an unrelated memory from third grade, stitching together emotional residue from years apart into one disjointed, dreamlike narrative. This might explain why dreams so often feel like a strange remix of your life, rather than a straight rerun of it. You're not watching yesterday's footage. You're watching your brain test new connections between old footage, looking for patterns, meanings, or associations it hasn't tried before. Some researchers have gone so far as to argue that this is where a meaningful share of human creativity and problem-solving actually originates, not in conscious, deliberate thought, but in the unsupervised remixing that happens while you're asleep and unaware. It's happening at all. It's happening at all. An emotional reset button. There's a third major theory, and it concerns emotion rather than memory or threat specifically, though it overlaps with both. Sleep researchers have observed that REM sleep appears to function as a kind of overnight therapy session, stripping the emotional intensity off a memory while leaving the factual content intact. In one notable study, researchers showed participants emotionally charged images and measured activity in the amygdala, the brain's alarm system, both before and after a night of sleep. People who slept showed a measurably reduced amygdala response to the same images the next day, while people who stayed awake for the same period did not. The memory of the image was still there. The emotional sting attached to it had been dialed down. The chemistry behind this is telling. During REM sleep, the brain experiences a sharp drop in noradrenaline, a stress-related neurotransmitter that is otherwise present throughout your waking hours. Some researchers describe REM sleep as the only time your brain processes emotionally difficult material in an environment essentially free of the stress chemical that would normally make that processing painful. Under this view, the reason your dreams replay an argument, a loss, or an anxiety from your daily life isn't punishment. It may be the closest thing your brain has to a built-in mechanism for taking the edge off of pain, one rehearsal at a time, across many nights, until the memory stops hurting the way it once did. This theory has an uncomfortable flip side. People with PTSD frequently experience the opposite of this process. Their nightmares don't fade the emotional charge of a traumatic memory. They appear to lock it in, replaying the same traumatic content with the same intensity, night after night, without the usual softening effect. Some sleep researchers believe this points to REM sleep malfunctioning under chronic trauma, rather than performing its usual emotional regulation job. If that's correct, recurring nightmares in trauma survivors aren't simply unpleasant. They may be a visible sign that the brain's normal emotional processing system has gotten stuck. What happens when you're stopped from dreaming? Perhaps the strangest evidence in this entire field comes from REM deprivation studies, where researchers selectively wake subjects every time they enter REM sleep, while still allowing them plenty of total sleep time overall. The subjects aren't sleep-deprived in the conventional sense. They're specifically dream-deprived. The results, first documented in the late 1950s and replicated many times since, are consistent and a little unsettling. People deprived specifically of REM sleep show increased irritability, difficulty concentrating, and heightened anxiety, even when their total hours of sleep remain normal. More strikingly, when finally allowed to sleep without interruption, subjects experience what's called REM rebound. They enter REM sleep faster than usual and spend a disproportionately large share of the night there, as if the brain were racing to make up a missed quota. This is one of the strongest pieces of evidence that dreaming isn't an incidental byproduct of sleep. It behaves like something the brain actively needs, tracks, and will go out of its way to recover if denied. Animal research adds another layer. Virtually every mammal studied shows REM sleep, including animals that face very different survival pressures than humans, dolphins, cats, mice, even platypuses. Some birds show a reduced form of it too. The near universality of REM sleep across such a wide range of species, each with wildly different brains, environments, and threats, suggests whatever function it serves is fundamental, rather than a quirk specific to human cognition. Why the forgetting might be the point. Which brings us back to the original mystery. Why does almost none of this survive contact with waking consciousness? One explanation lies in simple brain chemistry. The hippocampus, your brain's primary memory encoding structure, relies heavily on certain neurotransmitters to commit experiences to long-term storage, chemicals that are sharply reduced during REM sleep. Without them at full strength, the brain has a much harder time transferring the dream experience into a memory you can later retrieve, even though the experience felt, in the moment, completely vivid and real. There's also a more functional argument for forgetting. If dreams really are a nightly process of rehearsing threats, replaying memories, and softening emotional pain, then remembering every single one in full detail every morning might actually work against you. You'd wake up carrying the emotional residue of 100 small rehearsed disasters alongside your actual memories, with no easy way to separate which experiences truly happened to you and which were simulations your brain ran for practice. Forgetting may be less a flaw in the system than a necessary clean-up step. The brain quietly closes the simulation, keeps whatever adjustments it made to memory and emotion, and clears the raw footage so it doesn't clutter your sense of what's real. So when you wake up at 6:47 a.m., with that dissolving fragment of a dream slipping out of reach, you're not failing to hold on to something valuable. You're watching, in real time, the very last visible step of a process your brain has been running on you, every night for your entire life, one you were never really meant to remember, and one that may be doing more to shape who you are than almost anything you experience while awake.